Welcome everyone to this Bright Talk session, which is brought to you by the Storage Networking Industry Association. SNIA works to develop storage-related standards and has over 2,000 members from 185 companies. You can learn more about the work done by SNIA by going to snia.org/technical. My name is Richelle Ahlvers. I am a storage management architect at Broadcom, and I have been involved with SNIA for many years. I am the chair of the SNIA Scalable Storage Management Technical Work Group, or the SSM TWIG, which is where the SNIA Swordfish specification is being developed. And I'm also on the board of the SNIA Storage Management Initiative, which is sponsoring the work of the Swordfish specification. I'm here today to facilitate this webcast, and we'll be back to cover the Q&A session at the end. During this Bright Talk session, we will talk about how SNIA Swordfish is expanding to cover NVMe and NVMe over fabrics. NVMe and NVMe-oF lack native efficient remote configuration and provisioning management mechanisms to enable scaling to large converged infrastructures. This is something Redfish and Swordfish can provide. This webinar will provide an overview of the work in progress to map these two standards together to ensure NVMe and NVMe-oF environments can be represented entirely in Swordfish and Redfish environments. Your presenter today is Rajalaxmi Angadi. Raj is a senior engineer at Intel Corporation. She has over 14 years of industry experience architecting, developing, and doing performance analysis of storage systems and fabric technologies, including NVMe and NVMe-oF. Assisting Raj during the Q&A session today will be Phil Cayton. Phil is the senior staff engineer at Intel Corporation with 25 years experience developing and researching non-volatile, local, and remote storage and fabric technologies, particularly NVMe, NVMe-oF, NVMe-MI, InfiniBand, and iWarp architectures, resulting in over 20 patents. Both of them have been heavily involved in the development of schemas and mockups for SNIA Swordfish in the SSM TWIG. They've also authored multiple technical proposals and contributed to the NVM Express consortium. If you have any questions you'd like to ask during the presentation, just type them into the Bright Talk Ask a Question box. I will be collecting the questions and we will answer them during the Q&A session following the presentation. We expect to have about 10 or 15 minutes for the Q&A session. Also, if you would like to get a copy of the slides, you can find them as an attachment associated with this Bright Talk session. Some of the slides in the presentation today contain a lot of detail, so you might find it useful to expand your view to full screen by clicking on the expand icon near the lower right-hand corner of the display. With no further ado, I will now turn things over to Raj for the presentation. Raj?
Yeah. Thank you, Richelle. Hello, everybody. Like Richelle introduced, today we are presenting NVMe and NVMe-oF fabrics configuration and management with Swordfish and Redfish. We have a little disclaimer. The information that we are presenting is a snapshot of the work in progress within SNIA SSM working group and is subject to change as it is evolving at faster pace. We even worked on it in today morning in our meeting. You can refer to SNIA.org Swordfish and NVMexpress.org for more information. The agenda for today is we will go over a brief of what NVMe and NVMe-oF fabrics is. We will see resources that are to be managed in NVMe and NVMe-oF fabrics. We will see what DMTF-Redfish and SNIA Swordfish is, followed by how NVMe and NVMe-oF fabrics are managed using SNIA Swordfish. Let's see what's NVMe. NVM Express is the industry standard for non-volatile based memory solutions. It is developed by an open industry consortium for client and enterprise systems. It is architected from ground up for non-volatile memory, which allowed the command sets to be more efficient as compared to other legacy command sets. It is designed to scale across client, enterprise, and cloud solutions and is supported on all major operating systems. In a nutshell, NVMe is a high-performing storage solution with low latencies as it has highly parallel queues, and also because it is PCIe direct attached, removing latencies coming from traditional storage controllers. It is a host software to communicate with an NVM subsystem over PCI Express. Hence, it is very efficient. NVMe 1.4a is the current spec that is out there. There is a user space NVMe driver with SPDK implementation, which is based on user space asynchronous polled mode operation as well. The diagram on the right shows the example of storage stack of local NVMe, that is NVMe over PCIe. Now let's look at NVMe over Fabrics. NVMe over Fabrics is the specification to access NVMe over the Fabrics interconnects like Ethernet, InfiniBand, or Fiber Channel. It extends the efficiencies of NVMe but also retains NVMe semantics like low latencies, multi-queues, etc. It is built on the base NVMe architecture, and the same NVMe commands are used with thin encapsulation and are sent across the fabrics, and hence there is no protocol translation overhead. NVMe over Fabrics is one architecture for fabrics but is not fabric specific, and lets the remote storage access with transports like TCP, RDMA, or Fiber Channel. NVMe over Fabrics presents an abstraction so that a NVM subsystem can be exported over a fabric. There is a provision to have unrestricted access to NVMe over Fabric subsystem, in which case it can be accessed by any host or initiator, or NVMe or Fabric subsystem can be limited to specific initiators or hosts. It is basically the access control feature. The example in the diagram shows NVMe or Fabric's target represented by rightmost block. The target in this example has PCIe attached NVMe. The NVM subsystem is exported using RDMA transport in this example. The application on the host or initiator, which is shown by the left block, can access the subsystem with RDMA transport. The transports could be TCP or Fiber Channel. The latest spec of NVMe or Fabrics that's out there is 1.1, which also includes features like multipath improvements, asynchronous namespace access, to name a few. Now coming to management of NVMe. The resources to manage in NVMe are controllers, subsystems, and namespaces. A namespace is a quantity of NVM that may be formatted into logical blocks, and namespaces are identified by namespace ID. An NVMe controller is the interface between host and an NVM subsystem to access the namespace. A controller executes commands submitted on submission queue and posts completion on completion queue. For a local PCI attached NVMe, a controller is a PCI Express function. Controllers are identified by controller ID. An NVM subsystem includes one or more controllers and 0 or more namespaces and 1 or more ports. This example shows an NVM subsystem with 2 namespaces, 1 controller, and 1 port. Subsystems are identified by subsystem NQN. NQNs are NVMe qualified names which uniquely identify NVMe entities like targets or hosts. The controller ID value, when combined with NVM subsystem identifier, forms a globally unique value that identifies the controller. These resources can be managed with operations like set configuration, get configuration, retrieving health status, or reset operations. When it comes to management of NVMe or fabrics, broadly we have management of resources at the initiator or host endpoint, resources at target endpoint, and the fabrics that is used to connect both ends. On the initiator endpoint, it is about managing initiator side hardware and or software. Initiator, also called as host, accesses the NVM storage on the target side. The target endpoint includes management of NVMe fabric subsystem, namespace, and controller. Fabrics management includes configuration of ports, IP addresses, etc. to enable a fabrics to be used for NVMe fabrics. Now let's expand on to the target and see how it looks. The diagram on the slide shows an example of NVMe over target, NVMe or fabrics target. In this example, we have a physical storage, and a namespace list is a list of namespaces that are available on the physical storage. The storage can be logical instead of the physical one. The dark blue box at the center is an NVMe or fabric subsystem that can be accessed by a remote host or initiator. It is constructed by using one or more namespaces from the namespace list and using one of the fabrics port. Access to NVMe or fabric subsystem could be configured as restricted or unrestricted. When unrestricted, the subsystem can be allowed to be accessed by any host or initiator. When restricted, only specific hosts are allowed access, and it is specified by known host list. The known host list can be empty for unrestricted access of NVMe or fabric subsystem. We have three types of controllers: I/O controller, administrative controller, or discovery controller. I/O controller is a general purpose controller that supports commands that provide access to logical data and metadata. Administrative controller provides management capabilities. Discovery controller is a special type of controller used with NVMe or fabrics to provide access to discovery log pages. Now that we have seen what is NVMe, what's NVMe or fabrics, and what are the resources that needs to be managed, let us dive into what is DMTF-Redfish and SNIA Swordfish is. DMTF creates open manageability standards spanning diverse, emerging, and traditional IT infrastructures. Redfish is one of the standards from DMTF. It is designed to deliver simple and secure management for converged, hybrid IT, or software-defined data centers. It includes protocols, schemas, host interfaces, and profiles for management of a server. The design is based on secure RESTful APIs, OData, and HTTP operations. Three main categories that it manages are systems, that include CPUs, memories, devices, etc. Managers could be BMCs or enclosure managers, and chassis, which are racks and blades. It is expanding to cover data center infrastructure, fabrics, and network management. Now coming down to SNIA Swordfish. Storage Networking Industry Association, SNIA, is an organization that leads storage industry in developing and promoting vendor-neutral architectures and standards which facilitate efficient management, movement, and security of information. The SNIA Swordfish specification helps to provide a unified approach for the management of storage in hyperscale and cloud infrastructure environments. It makes it easier for IT administrators to integrate scalable solutions into their data centers. It extends DMTF-Redfish specification for storage management. It also includes secure RESTful APIs separating management model from transports like HTTP. It deals with resources expressed based on OData and JSON schema, and resources are accessed through usual HTTP operations like GET, PUT, POST, etc. Swordfish is now encompassing NVMe and NVMe-oF fabrics, and we will see how in the coming slides. But first, let's see what is Redfish. Redfish presents three major collections and everything else is a service. The collections are shown by dark blue boxes on the slide. Systems include processors, disks, memories, network interface cards. These are logical resources. This is also the data plane. Chassis is the sheet metal view, and we have power and thermal living there. This is the physical plane. Chassis can also include disks and have dotted line going into computer systems to represent storage under systems. Managers can be BMCs, chassis managers, or rack managers. These are extra processors that are neither doing data plane nor physical plane management. This is the Redfish model, which includes storage. This example shows drives in the model. These are set of drives of the server or system. These can be NVMe or SATA drives, for example. Redfish model can best cater to local storage. There is work going on along with the Swordfish to support NVMe and NVMe-oF fabrics. With disk arrays getting large, such as in JBoF or storage array kind of environments, Redfish is not optimized for scaling or shared storage resources. A computer system with attached storage can have storage drives and volumes and namespaces. But when the storage starts to scale to include complex constructs like storage pools, consistency groups, etc., it becomes difficult to keep track of the mapping. And which is why we have Swordfish. There was a need for retaining Redfish and also a migration path from Redfish. With Swordfish, you can enhance schemas to add common functionalities that are needed to scale storage. We add incremental functionalities that large-scale systems can take advantage of, like storage groups for mapping and masking functionality, or consistency groups for taking care of redundancy functionality or file systems. The primary Swordfish elements are volumes for block addressable storage, file systems for file addressable storage, storage pools, which are nothing but storage capacities that can be used to produce volumes or other storage pools, storage groups, which are sets of volumes and endpoints that are managed as a group. This is used for mapping and masking. Consistency groups are nothing but set of volumes that are treated by an application or set of applications as a single entity, and endpoints which represent one end of a protocol-specific connection that supports sending or receiving messages. Endpoints are abstraction of the connections from the fabric's perspective. moving on. Now that we have seen Swordfish storage model, let's see it with NVMe. It is first time there is a three-way connection between DMTF, SNIA and NVMe. To explain, I have three steps. First, we will see the mapping diagrams, in which we will have the mapping of NVMe and Swordfish. Then we will see the Swordfish model, followed by parts of the schemas. The figure on this slide shows a simple NVMe device model on the right side of the blue line and its mapping to the Swordfish on the left side. Right side of the diagram shows the device model of the system with local PCIe NVMe storage, and we can see I/O controller, subsystem and namespace resource. This model does not have endurance group or set, hence that portion is grayed out. On the left, we have corresponding Swordfish elements. These equivalent elements are shown by the green bidirectional arrows. The purple and blue arrows show the relationship between objects in Swordfish and NVMe respectively. There are more complex models that we are working on, and vendors can build and expand on top of it. This slide shows NVMe with Swordfish. The slide shows Redfish Swordfish model for simple local PCI attached NVMe storage. At the top, we have Redfish service root, which defines chassis, systems and storage systems. We see sys1, which is an instance of the system, and we have storage collection under it. We have simple NVMe SSD subsystem as storage instance, which has one controller and one volume. We have namespace called simple namespace under volume collection and one NVMe I/O controller under controller collection. We see there is one drive called simplest NVMe SSD under drives collection, which is under chassis, and we have a link to this drive from simple namespace, as this namespace comes from this drive. SNIA Scalable Storage Management Working Group is defining schemas for mapping and managing NVMe and NVMe-oF fabrics. Mockups are used as a development tool, a tool that Redfish used and Swordfish has also adopted. We create systems using mockups and then start enhancing and tweaking them. Mockups are nothing but snapshot of state in time of different types of systems. They are published at http://swordfishmockups.com, and they are just a representation of the implementation. Please note, NVMe mockups are not there yet. They are done within the working group as of now and will be there soon. This is an example of a storage system called sys1, highlighted by the first block. This system contains storage at the link sys1/storage, which is highlighted by the second block. The disk or drive lies in the chassis in this example. Hence, we have a link to chassis that is highlighted by the third block. Continuing on, continuing the model from the previous slide, we now get into storage collection, which is shown by the left side, and on the right we show that this storage has got one volume and one controller. Moving on to see how the namespace is constructed. Namespace lies in the link which is shown by the highlighted first block. Namespace is under volumes collection, and we have namespace with ID 1 as an instance. The second highlighted block shows the capacity for this namespace. The third block shows various features for this namespace, like if thin provisioning is supported or not, whether atomic transaction sizes are supported or not, etc. An example of HTTP GET operation to access the namespace is shown at the bottom of the slide. Now let's see how controllers are defined. Storage controller is defined as an array. This example shows one controller with ID 14, which is highlighted by the arrow, and has definitions for model, serial number, etc. Continuing on the controller, it also defines various properties for this controller shown on the right side. This example includes controller properties and attributes like arbitration burst size, multipath I/O, and namespace sharing capabilities, maximum data transfer size, NVMe version, etc. We also see attached namespaces highlighted by the block at the bottom, which tells which namespace or volumes are attached with this controller. HTTP operation on controller can be done similar to the one shown for the namespace, but along with the corresponding path for the controller. This is the example of an NVMe with endurance group and set, and this is the mapping model which shows simple NVMe with one endurance group and one set. Just like the previous model, we have I/O controller, subsystem and namespace mapped to the corresponding Swordfish elements. Endurance group can be mapped to storage pool, and set is also mapped to storage pool. And we can have storage pools within storage pool. And like we see in the diagram, we have two different storage pools here. Endurance group is a collection of NVM sets, and a NVM set is a collection of NVM. We have mockups for this model similar to the one explained in the previous slides, but with endurance and sets added to it. Now moving on to NVMe or fabrics. This is the mapping model that shows NVMe or fabrics. To recap, the resources that we manage in NVMe or fabrics target are subsystem, controller, and namespace, and fabrics. In previous slide, we have also seen that NVMe or fabric subsystem is constructed with namespaces from list of available namespaces, basically creating an abstraction over the underlying namespace resources. Again, we have the bold blue line dividing the diagram into two sections. The right side of the line shows the device model and the left side shows Redfish Swordfish model. In this example, we have underlying NVMe resources to create the NVMe or fabric subsystem that can be exported. This underlying NVMe device model and its mapping in Swordfish world is shown in the central block of this diagram, that is grayed out. And we have seen similar model in our previous slide. The far right end shows the resources of NVMe or fabric subsystem, and I have these pointed out from the miniature NVMe or fabrics diagram on the right top corner. And we see that the underlying device model is pointing to the central block, and the NVMe over fabrics subsystem is being pointed to the rightmost orange blocks. The far right end, has got the orange blocks that show NVMe fabric subsystem, and the corresponding Swordfish elements are shown on the far left side purple blocks. Just to note, the namings on this resource blocks are not the standard defined names. Again, we have the green arrows showing the 1:1 mapping between the blocks, and we have the purple and orange arrows showing the relationship between the blocks within the individual models. The mockups that the working group is currently working on are simple SSD with endurance groups and sets, JBoF, which is just a bunch of flash, fabrics attached array, and many more. To summarize, schema modeling is currently work in progress within SSM working group. SNIA Scalable Storage Management Working Group is working with Redfish and NVM Express to define updated features. So we have smart properties, domains, etc. included in our schemas. We will possibly have initial spec incorporating management of NVMe and NVMe fabrics by Q2 2020. You can review the mockups at swordfishmockups.com when they are available and ensure that they are sufficient and defined completely. NVMe fabrics and NVMe mockups are yet to be uploaded on swordfishmockups.com, but they will be there soon. You can create your mockups and submit. You can use various tools that are available to verify your schemas. And finally, you can join SNIA SSM technical working group and help in defining the use cases. Thank you. That is all I had. And I'm giving back to Richelle.
Thank you, Raj. Excellent overview. All right, and we'll now transition into our Q&A session and answer as many of your questions as we can. Just as a reminder, please submit your questions through the Q&A section at the bottom of the screen, the Bright Talk Ask a Question box. We have several questions teed up, and let's see if we can't jump into a few of those. All right, first question. We've heard about NVMe-MI as out-of-band to manage NVMe devices. How does this compare and contrast to using Redfish and Swordfish? Phil, you want to take that one?
Sure. So, yeah, the Redfish and Swordfish models are for managing larger scale, data center levels, that sort of thing, installations, whereas NVMe-MI is more of the lower level out-of-band management of NVMe. And in addition, this will incorporate the NVMe and NVMe fabrics model, again, at the larger scale. Richelle, do you got anything else to add to that?
Yeah, I think the one thing I would add to that is that my cat is knocking things up, is that the Redfish and Swordfish mapping is agnostic of the exact mechanism, whether you're using in-band or out-of-band management at the lower level. This is intended to be a way to map whatever you're using to actually get the interface for those NVMe devices into the Redfish and Swordfish ecosystems, whether you're using system-level management or data center management, and bring that all together in that standards-based management you're using at the higher level. Okay, let's see. Next question. When are the next versions of the specs coming out? So when is the next version of NVMe coming out? We'll start with that one. a little bit generic question. So,
yeah, I believe it's happening in the second half of this year. I don't have a better date for you at the moment.
All right, it's kind of a generic question, so we'll just put it into pieces. The next version is when is the next version of Redfish and Swordfish coming out? These come out in stages, so I'll take this one. Raj has been talking a lot about coming out soon. Redfish and Swordfish are not synced because they're released by DMTF and SNIA, but we each have multiple release cycles a year. Redfish just released 2020.2. We are, as she just pointed out, Swordfish we're trying to get our next release out sometime here in Q2 to include a whole bunch of this NVMe work. So we expect to see, hopefully simultaneous releases of Redfish and Swordfish to support the incorporation of a lot of this new NVMe material. But we do both try and release multiple releases a year. So we expect to see, hopefully, releases simultaneously of Redfish and Swordfish to support this work. Let's see. Next one. How is Redfish differ from PLDM for out-of-band management? So I'll take that one as well. Redfish and PLDM is primarily focused at a little bit lower level. You can kind of think of it as a little bit of in the box, and Redfish sits above that as well. Redfish and Swordfish both sit at more of the system multi-system data center level. So think of it as a hierarchy. So PLDM will work at the in the box, intra box level, talking to potentially a BMC from a server perspective, and then above that, the BMC can then turn around and talk Redfish up and out. And then you have Redfish ecosystems above that. So that's kind of the hierarchy there. It's not a replacement. They partner together very well. And there are actually bridging technologies there. There's things like the Redfish device enablement that actually works within PLDM to translate if you want to have Redfish in low-level functionality embedded down in the system to basically have very tight coupling between Redfish and PLDM. So it's Redfish device enablement for PLDM, to be very specific there. Let's see, can we find the deck presented online? It is currently in the attachments for this presentation. We will also look at making it available on SNIA.org as well. Okay, never mind, so folks can find that there. Okay, next question. What is used to restrict the access known list? So Phil, you want to take this one?
Yeah, so that's the host enqueuing. It's an identifier for what host wants to attack, be able to attach to what subsystem. So it's not network based. It's based on the identifier of the actual host.
Okay, let's see. Next question. Why were Redfish and Swordfish chosen for NVMe-oF management? It's kind of an interesting question. A lot of the same companies are engaged in both NVMe, NVM Express, as well as driving the standards-based management for DMTF and SNIA. And as I hopefully described a little bit ago, there's a lot of kind of layering in terms of different levels of standards and standard-based management. So the positioning for Redfish and Swordfish as the ecosystem for server management, data center management is really pretty straightforward and something that's being well accepted in the industry now. And so we're seeing a lot of movement for network management integrated into that, and it's really a logical partnership there to integrate definitely the management of the NVMe devices into that, but also to move the NVMe-oF as we're moving to managing systems and data centers with Redfish and Swordfish into that, to enable the NVMe-oF environments as well moving forward.
Also, if I may, it's also a matter of scale, right? The Redfish and Swordfish are large-scale installations in complex ecosystems and infrastructures and usage models. Smaller infrastructures and ecosystems, may not require something like this.
Yes. Okay, let's see. There's a question about a specific slide. It was on slide 14. What about the mapping of ecosystems? I'm going to pop back to that one. Okay, I think the primary question here is really that we kind of talked a little bit about, here's how we map the I/O controller concepts and the volumes. Primarily the mapping of subsystem, and Raj, you may want to pick up here and talk a little bit more about this too. But primarily we're mapping the subsystem to the storage schema in Redfish and Swordfish. So there is an existing schema there that is where subsystem gets mapped to. Storage is, you can think of it as the same place we actually map subsystems. It's exactly the same notion for traditional storage as well.
Yeah, that's right.
All right, let's see. So who are the major early adopters of Redfish and Swordfish? Well, Redfish is really pretty straightforward. It's pretty much all of the major server vendors. You can go to DMTF.org/Redfish and see all of the promoters and supporters. You can also go look out on the internet and find lots and lots of references. So there are at least a good dozen implementations there. We're starting to see also some of the same implementations on extend to support Swordfish. We have we're a little bit behind the curve. Redfish was around a little bit before Swordfish, so we're starting to see some more initial implementations and more complex functionality starting to roll out with Swordfish. But from a Redfish perspective, we have a lot of implementations, including a lot of storage implementations using basic functionality. Let's see. Following up on the NVMe-MI relationship question. Is the view that Redfish and Swordfish are at a box-to-box level and PLDM and NVMe-MI are in box? Does the Redfish and Swordfish schema define how Redfish operations are translated to NVMe-MI operations at the BMC? So the short answer to that is kind of no and no. The schema, the Redfish Swordfish schema is it's not a how at this point, it's a what. We're not, at this point, none of the things we're doing here have anything to do with how or where anything is implemented. The mapping from the NVMe functionality to Redfish and Swordfish is completely agnostic of where anything is implemented. You could have everything implemented. You could have a Redfish service implemented in an IT-attached drive in this model. You could have absolutely everything mapped, on a host-based implementation with the service coming up through, coming up and, mapping down through whatever interface you want to get to the NVMe devices. The point being here that this is the mapping of the functionality to get it into that client level and user level view into the Redfish and Swordfish environment. We're making absolutely no assertions whatsoever about where or how that implementation happens. Phil, anything you'd add to that, or?
No, I think you did it very well.
Let's see. One more question here. Let's see. Are there SDKs that implement Swordfish and Redfish on the initiator and target side? There are a lot of open source tools that are made available from both DMTF and SNIA that help accelerate implementations. We have and Raj alluded to this in terms of, talking about the mock-up and talking about some of the ways that we do development. We provide those, you can find those at github.com/DMTF and find a bunch of the open source tools there. You can find them at github.com/SNIA as well. So there are tools to help you accelerate your development. There are not at this point full reference implementations, but we have everything from tools to help you generate mock-ups, generate schema, generate static implementation. We have emulators. We have a full range of test tools, and everything is available in open source. So we would encourage people not only to use those, but also to enhance them and to contribute your enhancements back. SNIA is also working to develop a conformance test program that will also be based fully on open source tools, so that as we flush out and develop both the standard storage as well as the NVMe environments, there will be conformance testing and conformance test logos and test suites available for folks to certify conformance. That's not the right phrase. But to basically validate conformance with the specs and the profiles that we're working on. So there's a lot of infrastructure there, but not necessarily in the form of an SDK. All right, how are we doing on getting through? Let's see. All right, so then do you see any of the other questions that I missed going through here?
The early adopters question, did you answer that one?
I did.
Yeah, fair enough.
All right. Is there any other, if folks had any other questions to submit, please try and squeak those in the last little bit here. We'd like to thank everyone for watching, joining and watching this Bright Talk session. And we hope you now have a better understanding of what's going on with Swordfish, NVMe, and NVMe-oF management. Remember that you can easily find more information about Swordfish at SNIA.org/Swordfish. We would also love to have you join. If you have questions, ongoing questions, you can submit about what's going on with Swordfish schema. You can always submit questions at the swordfishforum.com. You can also find information about Redfish at DMTF.org/Redfish. And as I've already noted, the tools at github.com/DMTF and github.com/SNIA. Please take the time to rate this Bright Talk section. We hope you found it interesting and useful, and we thank you in advance for your positive reviews and comments.
Yeah, I think I want to just add one thing, that we were not having enough time to show all the NVMe or fabrics mockup and all the different models that we are working on, but the model that we showed was just one example of simple one. Yeah. And then we, like Richelle said, we have more of them available in our working group.
Thank you, Raj. Yes, please stay tuned. If you're not already subscribed to the SNIA distribution list and you would like to see information on when the releases will be available, so please subscribe to the SNIA Matters newsletter and you will get notified when the next version of SNIA Swordfish releases and when those mockups are available on swordfishmockups.com. Thank you, everyone.
Thank you.